Hello everyone, I am Suprakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Let's start today's session. The topic the Laplace transform. Laplace transform is an integral transform used to analyze a linear system, and it convert time domain signal to the frequency domain. In the Laplace transform, we used to analyze the linear system, and it convert time domain function into, can say, complex frequency domain. There is some function ft, and the Laplace transform and ft is the fs is the representation of Laplace transform in frequency domain. Minus infinity to infinity e to power minus st into ft dt. This is the integral form to convert the Laplace time domain into frequency domain. Suppose if you take s, the frequency denoted as j omega. Suppose if we take this one, then what is this x j omega of xt? You can say this fs in place of xs. This is the ft, that's why we taken as fs. If you take xt, then xt have a lot of xs, like that. Minus infinity to infinity xt e to power minus of j omega t into dt. Sorry. For the Laplace transform, the absolute magnitude of this Laplace, it should be less than infinity. It means it should be absolute integrable. If the function is not integrable, then the Laplace transform will not exist. Then that function is absolutely integrable. Suppose if I, for the example, I taken that after I do. Suppose example is xt e to power 2t ut. If you have some function, you want to take a Laplace of this one, then you have to integrate this xt minus infinity to infinity xt dt. Then what is xt? Xt is equal to e power 2t into ut. There is a ut convert the limit from 0 to infinity e to power 2t to dt. And integration of this one is e power 2t divided by f2 from 0 to infinity. If you put the infinity here, then the whole function will be infinity. It means this will not converge the system, and this is not absolutely integrable. The value of this function integrable of minus infinity to infinity is infinity. This is not absolutely integrable function. That's why you can't be find the Laplace transform direct for this system. Then how to make the convergence of this one between less than the infinity? And that convergence factor is known as the ROC, region of convergence. Every function is not convergence to the convergence, but to find the Laplace system, all the function should be absolutely integrable. To make the system to be integrable, then you have to add something in the function to make that function into absolutely integrable function. Then that one known as the convergence factor, right? It means ROC, regions of convergence. Suppose for the same system, I use something to convert this one. It means if you find something like minus infinity to infinity xt, you have to add something e to power minus sigma t into e power minus of j omega t. This is the for the Laplace transform e power j omega t. Simply e power, you can say st. This is the simple function to convert this one. E power minus j omega t into dt. Suppose the whole system, suppose a function pt, then this should be absolutely integrable. The value of this one minus infinity should be finite number, not infinite. and this one known as the convergence factor. Suppose same factor if I add to this example, then what happen? How it will convert? Then xt is equal to e power 2t ut x omega, it will be minus infinity to infinity magnitude at e power 2t ut xt into e power minus of sigma t. First of all, integrate this one. Then it should, this unit function is change the limit. It should be minus 0 to infinity e power 2t into e power of minus sigma t into dt. And this will be 0 to infinity e to power minus of t sigma minus 2. If you take a common negative minus t, then this will be positive sigma minus 2 into dt. Then what is the integration of this one? Minus 1 upon sigma minus 2 and e to power of minus t something 0 to infinity. If this is the positive, for the convergence of the system, then sigma minus 2, it should be a greater than 0. If this is the greater than 0, if you put the value t is equal to infinity, then whole value will be 0. Then minus 1 upon sigma minus 2 e to power minus, if you put here infinity, this will be positive value, then nothing of this one matter. If you put the 0 here, then it will be 1, then final will be 1 divided. Then how is the convergence and what is the convergence factor? Is the R of C. It should be sigma greater than 2. If sigma is greater than 2, then only the system will be convergent. Neither, either the system will be not convergent, and who can't we find the Laplace transform of the system. That's why this factor will be added in your Laplace transform known as the convergence factor. This will define the region of convergence for any system. Yes, anyone?
So,
Yeah.
again, sir, the last one,
Uh,
the minus of 1 by sigma minus 2 and it by minus infinite minus 1. Then it become 1 by sigma minus 2 when the sigma is greater than 2.
yes, yes.
This part again to be.
Okay, okay, okay. Fine. Suppose if you integrate this one, then you find this will be a constant. Constant will be divided here. Then your function will be same thing e power minus t sigma minus 2 limit 0 to infinity. If you put that to infinity here, if you don't know about the value of sigma, then it should be positive and negative whole thing. It may be positive, may be negative. We don't know about that. Then you can't we find the exact answer of this. If this one will be negative, the negative will be positive. This negative also, the negative will be positive. It means e power t. E power t is means if you put the infinity here, the whole value will be infinity. It means this will be another convergence system. This is this is not a absolutely integrable system function. For to make this one to be a convergence or to be absolutely integrable function, then you should provide some value of sigma. That value should be a greater than of 2. If you provide the greater than 2, that time e power minus t only there. If you put something here, then this will be a positive value, and overall system will be negative only. In that case, if you put the value of e power minus infinity, then this value will be 0. then only 1 is present. If you put the 0, e power 0 is equal to 1. That's why the factor will become as ROC, known as the ROC. ROC
Okay, okay.
come for this one only. That one I define your function to at what places the system will be a convergence. There you can find the Laplace transform of the function. Then ROC will be defined. If ROC not defined, then you can't be find the Laplace transform of any function. Like that function. Because of the many function have like that, you have to find the integration of this one, the whole system will be infinity like that. Then if your integration will be infinity like this one, then that type of system can't define the uh, Laplace transform. To find the Laplace transform, you have to satisfy this function. Then it means your function must be absolutely integrable by adding this one. Okay, that's why this is known as the convergence factor. Also known as the ROC. Reason define the ROC. Okay, if the sigma is greater than 0, it's greater than 2, that value, the whole system will be absolutely integrable. Okay. The next thing of this one, that's why the S domain you can write for the Laplace transform, you can define as x sigma plus j omega in place of only j omega s is equal to j omega. Because of this only system minus infinity to infinity xt into this is the convergence factor also sigma t into e power minus j omega. You have minus t dt. Thus the system will minus infinity to infinity xt into e power minus j omega t is st j omega t 1 minus is common sigma plus j omega into t dt minus infinity to infinity xt. This will become minus of s t dt. Find the Laplace transform of any function. You can use this formula. Okay, this function added this sigma t minus of sigma t. This is define the plane of the system. This is the S. You can say this is S domain or S plane. What is the S plane? S is a function of sigma plus j omega. Then your convergence factor it may be minus infinity to infinity. This omega frequency also it may be minus infinity to infinity. Then how looks like a plane. This convergence factor denoted as the real axis, and this is denoted in omega axis, frequency axis. Then our whole system, a whole function, a convergence between them. This is denoted as the S plane or Laplace plane. This one defined as the convergence of the function. This is defined as the frequency. Description of the frequency over there. I tried two example, same thing by taking, and then what is the region of ROC to define. Suppose I have example xt is equal to e power of minus t ut. Second, same function e power minus t, take as a minus by 2 because the answer will be minus. That's right. E power minus of t. There is two function. Then check the what is the Laplace transform for both the system. For the final Laplace of this system, x s is equal to minus infinity to infinity e power of minus at ut into e power of minus t minus t dt. 0 to infinity for the ut, if there is a ut function, that's why it will be a 0 to infinity. Then e power of minus of at into e power of minus of st dt, 0 to infinity e to power of minus a plus st. To integrate this one, to minus by a plus s. Well, this will be the same system because of t something. We put infinity into here, then the whole function is 0 minus 1 by put infinity, this will be 0 minus if put 0, this will be 1. Now function is 1 by s plus a, you can say. Okay, let's check for other system. So minus here is also minus into dt into eta power of minus st into dt. Minus here, this will be minus ut. It means your integration limit is minus infinity to 0 e power of minus at e power of minus st into dt. Minus t common, a plus s same thing, minus, but here is something. If you take this thing is positive, suppose if you take this thing is positive, then what happen? Sorry, in minus infinity to 0. You take this whole system is positive, then this will be negative e power minus t, e power of minus t into, if you put the t in place is minus infinity, the minus minus infinity will be cancelled out, this will be a infinity. E power infinity will be infinity, the whole system will be not a possibility integrable. In this case, you have to check the a plus s would be a negative. If a plus s would be negative, the negative negative this will become a positive, e power minus infinity will be 0. That's why in this case you have to check this one is minus a minus s into t. Take a t is as a positive. Write it high right here. T is positive. Then take whole the system will be positive. In that case, only you can find the Laplace of this system. Then what happened this one? minus a minus of s, it will be same t minus of a minus of s minus t 0. If we put the 0 here, then this will be function will be 1, and if we put the infinity here, this will be a positive because of the convergence of the system. Then that's why this will be whole function 0. Then this will be minus 1 divided by f minus a minus s, or you can say this will be 1 by s plus a. In the both cases, Laplace transform will be same,
Excuse
but
me,
your
sir.
function will be different. And how can you justify furthermore? This is only the difference between this one is the ROC, region of
Uh,
convergence.
Hello, sir. Excuse me.
Yes,
I
yes.
think, sir, your the screen is not visible. Please, could you check once?
Which one has been? I think screen is running. Anyone others? Please answer me. The screen is visible.
Yes, visible.
So I don't know why it's not coming to me. I
Please,
will just connect.
no. You please disconnect and connect again.
Okay, sir.
Yeah. Okay. For this system, the ROC should be a s plus a should be a greater than of 0. We have to make the system should be absolutely integrable. It means the t should be a negative only. Then this whole system will be positive. In this case, s should be a greater than of minus a. S, it means the region of convergence, ROC sigma should be greater than of minus a. This is the region of convergence, ROC of this function. Next, for this thing, minus a, it should be in this case minus a minus s, that's one should be greater than 0. If this one greater than 0, minus a minus s, that's only the region, the only minus infinity we put here, then this function, all function will be absolutely integrable. Minus a minus s greater than 0, it means if you multiply the negative for the whole system, then a plus s should be less than of 0, because of if you multiply the negative from both sides, the whole greater than symbol will be changed. Greater than will be less than, and less than will be greater than, to multiply the negative for the whole system. That's why it will be negative. S should be less than of minus a. S, which means the region of convergence, minus a. It means this system is convergence when sigma is greater sorry, sigma is greater than of minus a. Then what is the region of convergence, ROC, of this system? Minus a is here something, and this also minus a is here something. For this system, ROC is here greater than minus a. This ROC is less than of minus a. This is only difference for the on the both example, but the Laplace will be same. Laplace transform will be same for the both. Just difference only the ROC. The ROC will be defined for this. This is the ROC. This is the ROC for this. Okay. You can define the ROC for the any system. You have to check the function, it will be absolutely integrable or not. If absolutely integrable, then what the value of so sigma of convergence factor. Okay. Simply, if you want to ask for the system, like an example, xt is equal to ut. All about, you know about that ut 0 to 1 infinity. This system will be convergent. You can check. Then what is the ROC for this system? Can we write the system? It will be like x dash t, sorry, x1, I written x1, e power 0 t into ut. You can write like that. And what is the excess? Decayation of minus infinity to infinity e power 0 t into ut into e power of minus fst into dt. 0 to infinity ut, this will be 1 e power of minus of st into dt. Minus of st, you can say this will be minus 1 by s e power of minus st. You put the value sorry, sorry, you put the value t is equal to infinity, then whole this is the 0. If 0 is putting 0, then whole value is 1. But what the region? This one. If this value should be greater than 0. If this one is a negative, s is negative, then this infinity will be make the system will be infinity. Then this value is 1 by s, but in this case the s should be a greater than 0. If s is less than 0, then this function will be negative e power minus of st. Then whole function makes e power st, because of there is some negative value. Then this infinity makes this function will be infinity. There is a region of convergence for the system means greater than 0. Means this is a 0. The ROC for the system is this one, like that. Same thing you can find for the xt minus of t. Let's check for this one. Minus infinity to infinity e power 0 t, take as a 0, u of minus t into e power of minus st dt. This will become minus infinity to 0, this will be 1 e power of minus st dt. Then the value of this one minus of 1 by s, same thing, e power of minus st minus infinity to 0. Okay, if you put the value 0 here, then whole function will be 1. This whole function will be 1. But if you put the minus infinity here, then this function will be infinite. It means not absolutely integrable. And how can you make this system absolutely integrable? Then in this case, s should be less than 0. It means negative. If this one is a negative, the negative negative makes positive value. Then if you put the value t is equal to minus infinity, then whole value will be 0. Then in this case, region of convergence is less than 0. It means the ROC of the e power u minus t is this one. Okay, fine. There's something here. What if you mix the system? Then how can you find the ROC for that system? Like suppose e power of minus 2t u of minus t minus e power minus 4t u of minus t minus e power minus 3t u of minus t. What is the Laplace of this system and what is the ROC of this system? Combined ROC. Find the x's. Same, use same formula minus infinity to infinity e power of minus 2t u of minus t into e power of minus st dt minus minus infinity to infinity e power of minus t 4t u of minus t into e power of minus st dt minus minus infinity to infinity e power of minus 3t u minus of t into e power of minus st dt. So because of the minus t, this system become minus infinity to 0 e to power of t as minus 2 minus s common dt minus same thing here minus infinity to 0 e to power of t minus 4 minus of s dt. For the system here same 0 e to power of t minus of 3 minus of s dt. This will be negative, negative will be positive 1 by minus 1 by minus 2 minus s here, then here minus minus 4 minus s, here is minus minus 3 minus 5. And what is the ROC of that system? For the convergence of this one, this should be a positive value. It means minus 2 minus s should be greater than 0. It means s should be a less than minus 2, should be less than of minus 2. ROC for this. For here minus 4 minus s should be greater than 0. It should be less than minus 4. Sigma should be less than of minus 4. 5 for here this should be minus 3 minus of s be greater than of 0, s should be less than minus 4 or minus 3, sigma should be less than of minus 3. Then combine ROCs, one is minus 2, the second is minus 4 greater less than minus 4, third one less than of minus 3. Plot the value of this one minus 2 minus 3 minus 4. In this case the ROC you have to select which one is minimum less than 4. That's why you have to select the ROC is this one. Which one is the most outers from the origin from here. If any system is greater than same thing, if you suppose greater than 2 greater than 3 greater than 4 like here, then you have to check the which one is the most far away from the origin. You have to check the ROC point for this system. In this case the ROC is this one less than of minus 4. Combined ROC is less than of minus 4. Okay. Check the next example for this. Find the Laplace of this system. E to power of minus mod of t. Mod of t, it means t should be a negative or positive. This is two things, positive or negative. Then we have to first take as positive, then et. Second thing take as a negative, then it will be a at. This will be a minus t, sorry, plus t. For the convergence of this, it will be a minus t. If you add this one, then we'll find this thing. It means e power minus of a mod of t is equal to e power minus t u of t plus e power at u of minus t. Then what is the region of convergence for this system? ROC. Same apply the Laplace rules. It will be minus infinity to infinity e to power of minus at ut into e power of minus st dt plus minus infinity to infinity e power of at u of minus t into e power of minus st into dt. This will become 0 to infinity e to power of minus t s plus a dt plus this will be a, because of this one minus infinity to infinity, you have to take this one for t a minus s into dt. We have to take this one with positive t because of the there is a minus of infinity limit. So minus infinity to 0 because of this will be u power minus t. Let's check this one. This will be 1 upon s plus a plus this will be 1 upon a minus s. But what is the ROC of this one? For this system, ROC should be s plus a greater than 0. That means s should be greater than of minus a, means sigma should be greater than of minus a. Second thing, a minus s should be greater than 0. A minus s should be greater than 0. Then s should be less than of a, sigma should be less than of a. Then you can see ROC for this system, sigma should be greater than of minus a and less than of a between them. What is this one? In our plot, sigma j omega. Suppose this is the a, same distance, this will be minus a, and ROC for this system is mid of this one like that. This is the ROC where the whole system will be converged. Suppose if you want to find something like example xt is equal to 1, then what is the Laplace of this one? Anyone can guess this system? What is the Laplace of this system? 1. Laplace of 1 is yes. No, no, no. In your mathematics, I think for 1 you can take 1 by s like that. Laplace of 1. But that's not fully correct. 1 by s is the only ut for the ut, not a 1. Because of the system will be unbounded system, this is not absolutely integrable, then you can't find the Laplace of the system 1. Or you can another thing you can say the ROC will not exist for this system. One, like just one. How can we return write the one? Suppose if you have a function, let's see, what is ut? You can say this is the ut 0 to 1 infinity. Then what is the minus of ut? 0 to 1. If you add this two signal, then you will find the 1 minus infinity to infinity. That's why 1 can be written as u of t plus u of minus t. But you have a doubt about this is here at 0, 1, 1. Can you add this one for the 2? No. Here is okay 1 because of minus infinity to 0. This is 1. 0 to infinity. This is also fine. 1. But at the point of 0, you can't say the what is the exact value at point 0 because the or function value is here to here only. In this case, in general way, it will taken as the average of this one, like a half of this system. Half is this one, half this one. When add. In this case, this is both mix the one. That's why if you add ut plus u of minus t, then we'll find the value is 1. Then the system will be right like that. Then for ut, what is the ROC for ut? Here I think fine. I will find already. For the u of t, ROC is greater than 0. Minus t, ROC is less than 0. For this one, ROC is greater than 0. For this one, ROC is less than 0. In your system, this is the 0. Greater than 0 is greater than 0 and less than 0. But there is no common ROC between them. Here is the common ROC for this one. That's why you can find the Laplace of this system. But here is no common ROC. No common ROC, not exist the Laplace. You can't find the Laplace of this one. Same thing you can say for the you know about the system, but I write what the Laplace transform of sine t. I think all you know about this system Laplace transform 1 divided by f square plus 1 like that. But this is not fully correct. Why? Because of the there is no common ROC for this one also. Sin t can be written as sin t into ut plus sin t into u of minus t. This is ROC greater than 0. This ROC is less than 0. No common ROC, no Laplace. Then how can you find the Laplace transfer of sin t? In our mathematics, the Laplace transform of sin t, it means the Laplace transform of sin t into ut. you have to add some function also. This one you can find the Laplace transform. For the only sin t you can't be find the Laplace transform. Same thing here. For the one you can find the Laplace transform. There is one, it means your system is ut. It's taken as like that. Because you know about the your mathematical formula for the Laplace transform, I think it will retain as from 0 to infinity, not retain as minus infinity to infinity. But here in the signal, it will retain as the minus infinity to infinity. But in our mathematics, there is written as only 0 to infinity xt into e to power of minus t dt. This is already 0. It means the xt ut is there. If you take as infinity, then there is the xt into ut here, the hidden ut. In this case, if you find the Laplace transform for the sin t, but you can't find the only sin t transform. Okay. If ut, it means this is only this function. Only this function ROC will be exist because of ROC is greater than 0. ROC will be exist, then you can find the Laplace transform for this. Okay, what is the Laplace transform of delta t? And what is the ROC of impulse response? Response impulse signal. Simple way in simple question. What is the ROC of del function? Okay. For the x's, it will be minus infinity to infinity delta t into e power of minus st into dt. Then the whole function will be e to power of minus st into 0 equal to 1. Then there is a bounded, already bounded system. Then you can say only bounded system, the ROC exists at entire S plane. Entire S plane is the ROC. You can say anything in ROC. The function will be 1 only. Laplace of the delta t is 1 only. Okay. Leave it here. Let's start the properties of Laplace transform. And take the example, at least one example for every property for your understanding. First property is the linearity. Linearity says that if you have some signal x1 t is equal, the Laplace of this one is x1s, second one is x2 t, Laplace transform of this one is x2s. There is x3, which one is this one is the combined of 3 is equal to combine of a x1t plus b x2t. Then the Laplace of this system is equal to a x1s plus b x2s. It means you can find the Laplace transform individually, and then after you can sum of the two system, three system, in many system. This is the Laplace property known as linearity property. Second one, time shifting property. Suppose x1t have xt have some Laplace is xs. If there is some delay in time, shift something like t naught. T naught is a constant value, not t, time variable. Then you have to take some delay here also in s domain. Okay, wait, something there is a problem in my system. Okay, sorry. E power of minus t naught xs. If there is a positive advance signal, then this will be a positive. Okay, for the example, if ut, all of you know about this one, Laplace of this one is s, then what is the Laplace of t minus 4? This will be e to power of minus 4s divided by f s. You can find simply find this property without giving writing in the integral of this. Third one, time scaling properties. If some system have Laplace transform, this one is x's. If there is some scaling in this time domain, then mod of alpha x s by alpha. For example, xt is equal to e power of minus t 2t ut. You all know about this one. For at is s plus a, it means s plus 2. Suppose if you multiply this one, x1t have e power of minus of 4t into u2t. Then what happens? This one you can say 1 by mod alpha, it means alpha is 2, multiplication into time domain is 2 into 1 by s divided by alpha s by 2 plus 2, it means 1 by 2 into 2 divided of s plus 4, and means this become s 1 by s plus 4. If we scale the unit step signal, then the signal have no effect. The whole system you can write as 40 into ut. Suppose this one system started from 0 to infinity. If you multiply something in 0, then this will be 0 only. If you divide something in the 0, then the 0 will be 0. If you multiply something in infinity, this will be infinity. If you divide by something, that this will be also infinity. That's why there is no change in the ut function, step function in scaling. That's why u up to t is equal to same as u of t. Fourth one is time reversal property. Excess. Then what is the, if there is some negative minus t, simply s will be negative. Let's check for the example. E power of minus at ut. You know about this one? This will be a s plus a. But in the same case, if you multiply by a negative, this will become positive. This will be minus negative. Then this will become a minus s. Or you can say minus of s plus a. Or minus 1 upon s minus a. Next one is frequency shifting property. If there any have a time domain s naught t u xt, exponential function is there if in time domain, and this will shift to the function in s domain. If there is a positive, then this will be negative. If this will be negative, this is negative, then this will be the positive in this frequency domain. For example, x1t is equal to ut. Have Laplace is 1 by s. Take x to t e power of minus 3 into ut. So minus 3t into ut. And what happened this one? This will become s plus 3. If there is an exponential function is positive, then this will become negative. If there is a negative, then this will become positive. Something like this. So negative, this will become positive. S plus 3. We also know about this one. E power minus 3 is equal to 1 by s plus 3. Next one is properties, convolution properties. In time domain, you know about the convolution. You can't be directly multiply of this one. But in frequency domain, you can multiply directly. Like this. If there is a x1 t have some Laplace transform of x1s, and x to t have some Laplace transform of x to t, x to s. If xt3 have convolution of x1t, convolution of x to t, like then the Laplace transform of this one is x1 multiplication of x to s. For example, you know about the convolution of ut into ut. Unit step function convolution of this one is will be 2 into ut, which one is rt. Ramp function to convolution of the unit step signal is a ramp signal. Same thing in s domain, this will become 1 by s, this will become 1 by s, multiply the both 1 by s square. You know about the t have 1 by s square Laplace transform of t, and this one will be also rt. Second one, e to power of minus at ut convolution of ut. We can directly find this one also. Laplace of this one is 1 by s plus a into Laplace of this one is 1 by s. This will become s plus a. If you uh, isolate this one, s1 s plus a, then this will become 1 by a. You know about this one, 1 by s, 1 by s I have 1, simply a ut can say 1 minus e power of this one is minus at ut. Same thing in previous class. This one have convolution of this one is 1 by a 1 minus e power minus at ut. Okay. Next property is differentiation in time domain. Seventh property. Xt have Laplace transform of xs. Then if you differentiate of this one xt, you will find s xs minus of x0. Multiplication of s here. X0 have initial condition of this one. This is the initial value. Same thing if double differentiation here of xt will become s square xs minus sx0 minus of x dash 0 is to go to power 1. After that you start the differentiation of this one, then put the value 0. Like this one, if you have n differentiation of this one dt square, this will become s power n xs, first one only. Then after you start the initial condition of all the function s to power n minus 1 x0 minus s power n minus 2 x0 dot 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 minus of s2 power 0 sorry 1 x0. Then after start, this one will be x cube power 1 sorry dash, this will be dash 0 minus dot 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 x power n minus 1 0 dot. This will be a differentiation. After differentiation, you have to put the value after differentiate the time domain signal, then to the initial value of this one. This will also same, not a capital X. You can confuse here. Small x, take as small x. Xt differentiation of this one, write the here the initial condition of this one. Then after put it the t is equal to 0. Next one, differentiation in frequency domain. If xt have some Laplace transform of x's, if multiplication of t here in xt, then you have to differentiate this one minus d by ds into x's. For example, xt is equal to e power of minus at ut. Then we know about the Laplace transform of this one is 1 by s plus a. Then what is the t is xt? T into xt here. It means t into e power of minus at ut. Then Laplace of this one is be minus d by s 1 by s plus a. This will become minus, okay, write once again, s plus a inverse. This will be negative, negative will be positive. Then differentiation of this one will be s plus a minus 1 minus 1. This will be 1 upon s plus a whole square. Same thing for a ramp signal, you can find the Laplace. If ut have a Laplace transform 1 by s, then tut ramp simply minus d by ds 1 by s. This will become 1 by s square. Okay. Next property is integration in time domain. Ninth property is integration. Integration in time domain. If xt have some Laplace transform of x's, this if there is an integration of minus infinity to t x tau d tau have Laplace transform of x's divided by f s only. There is a one integration, there is one s. With two integration, there is s square, like that. For example, the ut have Laplace transform of 1 by s integration of ut minus infinity to t u tau d tau is the same as the ramp signal ut t into ut. If you integrate the ramp step signal, you have found the ramp signal. This is the ramp signal. The integration of this one will be 1 by s and divide by f s. Ut have a Laplace transform 1 by s. because of integration divided by s, it will become 1 by s square. Because of this one, you know, u tau, it means this is the unit for step. Then this is will to change the system value 0 to t. This will be 1 only. D tau. Integration of this one will be tau from 0 to t. You put the t is equal to t, 0 to 0. That's why this is t ut. Integration in next one, integration in frequency domain. Xt become xs. If there is some division in xt, then in Laplace there is an integration of s to infinity xs ds. This property is a rare case that we can use. Integration. If you there is an integration in time domain. Wait. If you there is a multiplication in time signal t in time domain have a differentiation in s domain. Can say here multiplication of t in time domain have a differentiation in s domain, and division of t time in time domain summation integration of the function in frequency domain. Okay. For the combine the signal and how you can find the Laplace transform by the properties of the Laplace transform. Suppose you have a signal, a system have in time domain e to the power of 5t u of t minus 1. Then what is Laplace transform of this function? How can you find the Laplace transform of this? You can find step by step by using the property. First one, take this one ut. If there is a ut, the Laplace transform of this one is 1 by s. Then after, if you have u t minus 1, then Laplace transform of this one is e to power minus s divided by f 1. Oh, so divided by s, because this is 1, that's why this will be only minus of s, 1s. If there is a 2, then this will be a 2s. Okay, this will be 1, that's why this will be s. Then multiplication of e power of 5t u t minus 1, this will become 5t. It means multiplication of exponential terms, then the shift in s domain, s plus 5 divided by f s plus 5. This is the Laplace transform of this one. Next example of xt is equal to sin t. Sin t you can find directly for the sin t, but you sin ut you can find. What is the Laplace transform of this? Okay, sin t can be written as e to power of jt minus e to power of minus jt in divided by of 2j into ut. We can common e to power 2j and e power jt ut we can multiply here minus e to power of minus jt u of t. Okay, this is the constant function you can common. Then apply the linear properties. First find this one Laplace transform, then find this one, then add the both. First one find e power jt ut Laplace transform of this one equal to minus infinity to infinity e power of jt ut into e to power of minus st dt. u2 makes the limits 0 to infinity e power of jt take a because of infinity you have to make this one is negative t, take a negative, then this will become s minus j into dt. And what is the ROC of this one? It should be s should be greater than j. That's only the region where this Laplace exist. Integration of this one will be absolute integrable. This will be minus 1 divided by of s minus j to this will be same e to power of minus t s minus j 0 to infinity. If we put the infinity here, then this will become 0. If we put the 0, this system will be 1. Minus minus will be 1 s minus j. Second one, Laplace transform of e power minus jt ut. Integration of minus infinity to infinity e to power of minus jt ut to e to power of minus st dt will become 0 to infinity because of ut e to power of minus t common. This will be s plus j into dt. Here minus 1 by s plus j common, then here minus t s plus j 0 to infinity. If you put the infinity, this will be 0 0, this will be 1 and value is 1 s plus j. Okay, let's combine the both. Laplace transform of sin t into ut 1 by 2j. First one For this one, I have 1 by s minus j minus 1 by s plus j. Take LCM, lower part, s minus j, s plus j, the 2j here. Denominator, this will become s plus j minus half s plus half j, 2j, divide by of 2j into s, a minus b, a plus b, a square plus b square minus, sorry, a square minus b square, j square. 2j will be cancel out. J square will be minus 1. That's why this becomes s square plus 1. Okay. This is the whole property of RT of Laplace transform. And how can you use to this one to find any Laplace transform? Okay. Next one, have causal system, and stability by the Laplace. What is the Laplace domain? And stability in Laplace domain. Okay. There are some rules. First one, have for the system to be causal, ROC region of convergence is right sided. Right sided, it means it goes to this one like that. Then the system will be causal. But if the all ROC is right sided, because right sided not means the system will be causal. It depends on some values. So first to note that this one for the system to be causal, ROC is right sided. But right sided ROC never guaranteed causality. It means you can't be say the all system have ROC is right sided, the system is be causal, not mean of this one. Because like that, if the ROC is there, goes to right sided, then this will system will be causal. But the ROC is here, but this will become right sided, then this will be not causal system. That's why you can't be. But for the system to be causal, ROC should be in right sided, not the left sided. If there is a left sided, then this will not a causal system. This is right sided, but have some region. That's why right is the right sided ROC never guaranteed to be causal. You can see here, this is a right sided, but this is not guaranteed to be causal. This is not causal, non causal system. This is a causal. Okay. Next one, for the anti-causal system. ROC to be left sided. Right sided and left sided. Do two ROCs is there. If it goes to right side here like that, it goes to left side like that. This one for the causal, this one for the anti-causal. But for the non-causal, it depend the origin of this one. If the zero is here and I start from here, then the system is non-causal. Zero is here, started from here, then the system will be non-causal. But if zero is here and it started from here like that, then this will be causal and this will be anti-causal. Be left-sided, but guaranteed anti-causality. But for the stable system, ROC must includes the j omega axis. For the stable system, ROC must include the j omega axis. For the causal and stable system, all poles must be left half of S plane. Anti-causal and stable system, right half of S plane. Okay. For the causal system, ROC should be right-sided. For the anti-causal system, ROC should be left-sided. Right-sided means like that, left-sided like that. For the stable system, ROC, it includes this one, j omega axis. If ROC is not included the omega axis, the system will be unstable. For the causal and stable system, the all poles would be left of S plane here. For the anti-causal, poles are here. Okay. For the example, suppose a system e to power of minus 40 ut. You know about the Laplace of this one is s plus 4. ROC of this one is should be greater than of minus 4. It means This is the ROC. That type of system known as causal and stable system. There is a right-sided ROC. Same thing. The next example have HT is equal to U T plus 2 e to power of 2s divided by f s. In this case, ROC is greater than 0. Pole is here, ROC is here. Right-sided ROC, you can say this will be causal system, but it do not include the j omega axis. That's why the system will be unstable. Okay. Same thing. For the same example, if you take as ht is equal to e power 4t u of minus t. This is the 1 power 4 minus s. Sigma is less than 4. Then ROC, this is a 4. Less than 4, it means left-sided ROC. The system also is stable and non-causal system. Stable because of this, this includes the j omega axis, ROC. Then next example, e power 80 ut is equal to have one s minus a. Here ROC is greater than a. A it means positive, a here, then ROC is here something. Right sided. This will be causal, but it will be not a stable system because this is not includes the j omega axis. Next one, for example, e power of minus 80 u of minus t. Have Laplace transform of this one is on s plus a, where ROC of this one is less than of minus a. In this case, this will is the minus a, ROC is here somewhere. Left-sided ROC. It means this will be the anti-causal and unstable. Unstable because of the this will not include the j omega axis. It means all the stable system depends on the ROC. Where is ROC exist? What is the Laplace of this signal? I've taken a question like that. If you want to make, find the Laplace of this signal, then what is the Laplace of this? You can simply do the use the formula of Laplace. This one minus infinity to infinity xt e to power of minus st dt. Okay, xt is this one, 1 from 0 to 1. It means the whole sum function integrable from 0 to 1, 1 into e power of minus st dt. No problem. This will become minus 1 by s and e to power of minus st 0 to 1. If we put 1 here, then minus 1 by s it should become e to power of minus s minus if you put the 0, then it will become 1. This will negative multiplication. You can say this will be 1 minus e to power of minus s divided by of s. This is the Laplace transform of this function. Same thing you can do from the equation. You can written this one as ut minus of u of t minus 1. Okay. Now simply you can find the Laplace transform. This will be 1 by s minus this. This will become e power of minus s divided by s. This was simple. 1 minus e power of minus s divided by s by the properties. Okay. Okay, class. I have to want to stop here. Okay. We may we'll meet the next Tuesday. Okay. Thanks. All Laplace properties ending. Then after that, I will start the next thing using by the Laplace find some equation. How you can solve the LTI system by the Laplace system like that. Okay, thank you.